Hello, dear students. This is B.K. Jalisha, Assistant Professor, Department of Mathematics, St.Josephs College of Arts and Science for Women, Hosur. Today, we are going to see the topic Propositional Logic in Discrete Mathematics. First, we should have a clear idea about logic and what is its part in mathematics, where it is applied, what about its rules. Logic is the basis of all mathematical reasoning. It has practical applications in areas of computer science as well as to many other fields of study. In mathematics, we must understand what makes up a correct mathematical argument, which is called as a proof. The rules of logic give precise meaning to mathematical statements. These results are used to distinguish between valid and invalid mathematical arguments. Next is about a proposition. A proposition is a declarative sentence. Declarative sentence means that sentence will provide us either true or false as an output, but not both at a time. Here are some examples. The first two statements given here, New Delhi is the capital of India. The second one, 2 plus 1 is equal to 3. Both the statements will be able to give the answer as true. Whereas the third one, 2 plus 1 equal to 2, will give us a false answer. So all these three statements is called as a proposition because these three statements providing us an answer either true or false value. Now coming with the next four examples given here. First one is an interrogative sentence. How are you? We are not able to give the answer as either true or false. Similar, the second one is a comment. So for this also we will not be able to provide a true or false as an output answer. The other two statements given here are mathematical equations, but we'll be able to provide the truth values as either true or false if we are giving or substituting the values of x, y, and z in these two statements. But now at present, it is not able to say whether it is true or false. So all the four statements given here are not propositions. Notation. We'll always use small letters to denote proportional variables. It is also called as statement variables. The conventional letter or the general letters will use to denote the proportional variables are P, Q, R, S, and so on. It is based on the number of proportions we are going to use to get the truth values. The truth value of a proportion is denoted by capital letters. If the truth value is true means it is denoted by capital T, and the truth value is false means it is denoted by capital F. Now comes the definition for propositional logic. The area of logic that deals with proportions is called propositional calculus or otherwise called as propositional logic. Next is about compound proportions. So if we are having two or more proportions, then we can join those proportions to get a new proportion using the logical operator. Then that new proportion is called as compound proportions. Here we have said logical operator. It means we are going to connect the proportions using the words and, or, if, then, if and only if, exclusive or converse, inverse, all those things we are going to see in the upcoming slides. Next is about negation. If suppose P is taken as a proportion means its negation is denoted by here. Negation of P is the statement giving the answer is it is not the case that of P. That is, if P is giving the truth value as true, then negation P will give the truth value as false and vice versa. Now let's move into the connectives topic. We'll now introduce the logical operators that are used to form new proportions from two or more existing proportions. These logical operators are called connectors. This I have explained in the previous slide itself. The first connective here we are going to define as conjunction. Conjunction is used to represent the word and. This is used to represent the word and the symbol we are going to apply here is cap. For the word and or conjunction, we are going to use the symbol as cap. Next, we see how we are going to define the truth table for the given proportions. Before going into the truth table, we should know how many number of truth values will be able to give based on the number of proportions taken. So here we have taken two proportions P and Q. So the formula to know the number of outcomes is 2 power n is 2 power n. Here n denotes the number of proportions taken here. In this truth table, we are taking two proportions. So the number of rows or outcomes we are going to provide is 2 power 2, which is equal to 4. So that's how we are defining. If suppose three variables we are taking, if suppose we are taking three, then according to the formula, 2 power n is equal to 2 power 3, which is equal to 8 ways of outcomes we can give here. So how we are going to give the truth values there? So if two variables are there, P, Q, two variables are there means we can give 2 true and 2 false. And for Q, alternatively, first one is true, second is false, again true, then false. So this is how we are going to give the possible outcomes. Next, if suppose we are considering three variables P, Q, and R, then we will be able to give 8 possibilities. So for P, we need to put 4 true values in the first and next 4 true values in the last rows. For Q, 2 times true, 2 times false. Repeat it. 2 times true, 2 times false. And in R, 1 true, 1 false, alternatively to repeat. So we'll get the possible outcomes of all the three proportions. This is how we are going to see the truth table, which is going to be defined in the next topics. So now let's see the truth table for conjunction. It is defined as the truth table for the conjunction P cap Q is true when both P and Q are true. Otherwise, it is false. So the statement gives if both are true, then the answer is true. Otherwise, it will be false. So only the first row is having both as true. So we are giving the answer as true. For all the remaining, we are giving it as false. Next, we can move into the next connective disjunction. Disjunction is used to represent the word or and it is notated by the symbol cup. The symbol is called as cup. So the truth table here it is defined for two variables. Its truth table definition is the disjunction P cup Q is false when both P and Q are false and it is true otherwise. So when it becomes false, if both the values are false means the answer will be false. Otherwise it is true because the first row both are true. Remaining two rows at least one is true, hence we are giving the values as true. Last one both are false, hence by the definition we are giving here it as false. Next connective is exclusive OR. Exclusive OR is denoted by the direct sum symbol and it is the proportion that is true when exactly one of P and Q is true, otherwise it is false. So the truth table of P and Q should possess exactly one value as true means we can give the answer as true. So it is satisfied by the second and third row. So we are giving the values as true, other are false. Next connective is conditional. So if P then Q, conditional is denoted by the single arrow. The truth table for conditional is P tends to Q will get the answer as false when P is true and Q is false. So first thing we need to check is P value. So here we are checking P value as true. So two rows we are having P as true. So for that, if Q is false, then the answer will be false is the given definition. So only the second row becomes false. All the remaining, it is opposite to that of the given statement. So it all took true values. Next is about biconditional. Biconditional means if P then Q, similarly if Q then P. So biconditional is the double side arrow notation. The truth table given for that is if P biconditional Q is true when both P and Q have the same truth values. So listen here, the first row both are true, same truth values. The last one is also same truth values false. So for those two we are assigning as true, the remaining as false. Now here is a small representation of the sentence into the logical operator notation. So given P statement as Nilesh learns discrete mathematics, Q denotes Nilesh will find a good job. We need to express these two statements into a connective B conditional Q. So P conditional Q is denoted by if then words to use the connector. If Nilesh learns discrete mathematics, then he will find a good job. So here are some practice questions for the above topics. Please go through with that. That's all about today's video. The next video will be on about converse, contrapositive, and truth tables on connectors. Thank you all.